Our solar system is a wondrous place with a single star, our sun, and everything that orbits around it: planets, moons, asteroids, and comets. What do we know about this beautiful solar system we call home? It's part of an even larger cosmos with billions of other solar systems.
Hi, I'm Jim Green, Director of Planetary Science at NASA, and this is Gravity Assist. With me today is David Grinspoon. He's an astrobiologist, a senior scientist with the Planetary Science Institute, and today we're talking about Earth's twin planet, Venus. David did some early work in his PhD on Venus. What was that like, and what did you do?
Well, when I was in grad school in the 1980s, there was this new idea about large impact events affecting planets. You know, we had recently discovered this amazing fact that Earth was hit in an event 65 million years ago that knocked out the dinosaurs and caused an extinction. So people were starting to wonder, what else have large impacts done in the solar system? And I had a couple of mentors who suggested that I look at some other atmospheres, and I started just being drawn towards the fact that Venus is so similar to Earth and yet so different, and wondering what large impacts did to Venus. And that led me to work on things like what happens when comets hit Venus, and what does that do to the amount of water in such a dry planet, and what was the early climate of Venus like compared to Earth under the influence of being pummeled by a lot of impacts. And it's basically how I learned to do climate modeling, was by considering these sort of weird scenarios of early atmospheres and what might have been happening to them under the influence of violent impacts.
Even though Venus is about the size of the Earth, it's very different in many ways. What do you think is happening on Venus that makes it so different?
Well, that's one of the very compelling questions about Venus, because it's so Earth-like in terms of its bulk properties. If you just ask the most basic questions, what's the size of it? What's the mass of it? Where's it located in the solar system? You'd say, wow, it's just like Earth in all these ways. And then you start looking at what's the environment like, and you go, whoa, that's not at all like Earth, because it's so incredibly hot and so incredibly dry. So it's evolved in a different direction. And so when you start talking about Venus today and comparing to Earth, you're led to these questions of not just what's happening there now, but how has it evolved, you know, and how did those two planets head down such different paths? And obviously for Venus, it's a story of somehow having lost its oceans and lost what we think of as a more pleasant climate a long time ago in the path, and trying to understand that sort of divergence of conditions away from what we believe was more Earth-like a long time ago.
So how does Venus help us understand what Earth's climate is like?
Well, it serves as an interesting laboratory for us to test a lot of our ideas about climate and atmospheric processes on a planet that, again, is somewhat Earth-like in some ways and somewhat very, very different in other ways. But, with climate and the environment, a lot of it is the same physics and chemistry in different situations. So, everybody knows about the greenhouse effect on Earth and how carbon dioxide is part of that. Well, picture a planet just like Earth, where the atmosphere is almost all carbon dioxide, basically. And what would that do to climate? It's an interesting sort of thought experiment, but it's also a real experiment, because we have this planet next door, Venus, which is basically all carbon dioxide. And many other aspects of Earth are sort of almost exaggerated on Venus too. You've heard about acid rain. The clouds on Venus are sulfuric acid, so it's sort of the extreme case of acid rain. So that's also allowed us to study, again, an Earth environmental issue in almost an exaggerated form. And so this is just something that kind of makes us smarter about the problems and the puzzles that we encounter on Earth by seeing them in an altered and sometimes exaggerated form on a nearby planet.
Venus isn't actually that very far away from us, nor is it very far away from the sun, in the sense that our two planets have evolved at the moment very differently. But what was Venus like early on in its evolution, do you think?
Well, that's a great question. And of course, that's one of the mysteries that compels us in our research and exploration, is to try to get a more clear picture of the earliest history of Venus. We have a lot of circumstantial evidence that leads us to believe it was a much more Earth-like planet a long time ago. For instance, there's the fact that Venus is so incredibly dry today. In fact, if you add up the amount of water on Venus and compare it to what we think is the amount of water on Earth. I say it like that because we don't actually know how much water is hidden inside the Earth, but it's something like 100,000 times as much water on Earth than on Venus, which is really strange because we picture them probably having formed with roughly the same amount because they formed nearby out of similar materials. So we think Venus had oceans, and we think it had a more sort of pleasant climate, possibly even for life early on, and we've got some other circumstantial evidence about that. So my best guess is that it was much more Earth-like early on. I would say an informed guess, but there's still a lot of mystery there and a lot of experiments we'd like to do and measurements we'd like to make to try to sort of pin down that early history much more clearly.
One of the things that's fascinated me about Venus is that it rotates in the opposite direction, and it rotates very slowly. How's that affected its evolution, do you think?
Yeah, it's an interesting fact that, almost all the planets rotate in the same direction as Earth does. So if you're standing on their surfaces, the sun rises in the east and sets in the west, like we're used to. If you were on the surface of Venus, assuming you could see the sun, which, would be hard because it's so cloudy there, but the sun would actually rise in the west and set in the east. And it would do so very, very slowly because the planet rotates incredibly slowly. So in fact, if you're on Venus, you could walk fast enough to keep the sunset in the same place. You could walk as fast as the sun is moving around the planet. I did that calculation once, and I was like, wow, well, that would be kind of neat. You could watch the sunset forever just by walking. But how that fits into the evolution is a fascinating question. We don't fully understand the cause of that. We surmise that it's related both to the early impact history of Venus, just as Earth's rotation and Earth's moon are related to the early impact history of the Earth and setting the Earth spinning in a certain way. The planets formed by these big collisions, and the final few were probably very violent. So the geometry of those final few collisions, which way they hit, probably really influenced that spin. But on Venus, there's also the fact that we have this incredibly thick atmosphere, 100 times almost as thick as Earth's, and that can cause a sort of drag on the rotation of the planet through what we call tides, atmospheric and solar tides, which are just these phenomena of the mass of the atmosphere itself can actually pull on the planet's rotation over a long period of time. So that might have to do with how slowly it's rotating. We're not sure about its total evolution of the rotation rate and over time. But as far as rotating in the sort of backwards direction, if you will, we think that probably has to do with large impacts early on in its history when it was still forming.
Yeah, that's fascinating. Maybe that means that over time, Venus will end up being tidally locked with the sun. And then we're going to have a completely different environment, perhaps, with the extremes in temperature on both sides.
Yeah, that's really an intriguing possibility that Venus, moving so slowly, could be on its way to being tidally locked, and that at some point, probably in the pretty distant future, I don't think we have to start revising our models too quickly, but it could actually become a locked planet, like we think a lot of these exoplanets are, where one side is permanently facing the star.
As you mentioned, Venus has this huge pressure and enormous clouds that are very opaque, but, we have been able to penetrate through those. One mission was called Magellan. What was the most important set of observations that came from the Magellan spacecraft?
Magellan was an amazing mission. It really revolutionized our understanding of this neighboring planet. Before then, we had a couple of pictures of a couple of spots on the surface from these Russian landers, which were amazingly able to operate under those extreme surface conditions briefly in the 70s and 80s. And we had a couple of sort of vague images from radar of parts of the planet. But with Magellan, we were able to orbit and basically get maps of the entire surface, almost the entire surface, by using radar, which, as you say, penetrates through those clouds, and it does sort of flash photography, almost bouncing radar off the surface, and then you see that image and you build up what the planet looks like. And that revolutionized our view of Venus in so many ways. One thing we learned was how volcanically interesting Venus is. Its surface is almost completely covered in one way or another with volcanic features. These broad plains, flat plains that we can think of as flood basalts, like we have some areas on Earth. The Pacific Northwest comes to mind of these big flood basalt areas, and then other kinds of volcanoes, these steep shield volcanoes like Hawaiian style shield volcanoes. So I think of Venus almost as volcano world, and it immediately sharpened the question of, is it still volcanically active? And ever since Magellan, we've been trying to nail that down, and we think we have some clues about that, but we don't have what we sometimes refer to as the smoking gun telling us it's definitely volcanically active. But now that we know from Magellan there's volcanoes all over the place, that's sort of the next question. Are they still going?
Right. I mean, the supplying carbon dioxide into the atmosphere, is that, believed to be because of the volcanoes?
Well, over the long term, yes. I mean, that's how CO2 gets the main way CO2 gets supplied to planetary atmospheres. But we don't really know if Venus requires an active supply now, because there may be nothing removing CO2 from the atmosphere. On Earth, we have this cycle where CO2 is supplied by volcanoes, and well, now by factories and cars too, but historically by volcanoes, and then it's removed from the atmosphere by these what we call weathering reactions that are facilitated by water running over rocks and pulling CO2 out, making carbonate rocks. Venus has no surface water, so it may not really have any way of removing CO2 from the atmosphere. But we do see other things in the atmosphere that may require an ongoing volcanic source. We see all these sulfur gases, SO2, sulfuric acid, and it may be that chemical reactions are always removing those from with surface minerals, reacting with surface minerals. So in fact, the sulfur gases we see on Venus today may require an ongoing source of volcanic gases.
Venus also is an easy planet to see. It's close to the sun most of the time, and during its passage in its orbit around the sun, it can be very bright because it can be close to the Earth. So I know many cultures have been thinking about Venus and placing them in their own histories, and so it has a fascinating role from that perspective. Do you have any favorite stories about that?
Yeah, I'm fascinated by the fact that because, as you say, nearly every culture, probably every culture, has stories about Venus. Because it is so bright and also has such a different kind of behavior in the sky than a lot of other planets, because it's what we call an inferior planet, meaning that it orbits closer to the sun than Earth. It just appears for a few months at sunset and then disappears, and then reappears for a few months at sunrise and then disappears. You'll never see it in the middle of the night in the midnight sky like you might Jupiter or Mars or Saturn. So it sort of has this sort of almost kind of playful behavior where it kind of flirts with us and then disappears and then reappears on the other side. And a lot of cultures had stories that reflected that. And one area that I love of this sort of archaeoastronomy is the Mesoamerican stories about Venus. The Aztecs and the Toltecs and the Mayans were really astute and impassioned Venus observers. And they were very good at predicting the motions of Venus and noticing, and it was tied into their culture and their origin stories, their beliefs. And they have these really neat stories about the Mayans called Venus Quetzalcoatl. And our Kukulkan in the Aztecs, it was Quetzalcoatl, but it was basically the same character. And Venus was the brother of the sun. And together, Venus and the sun would go into the underworld and do battle with the enemies of mankind. And that kind of makes sense because you see Venus, at sunset sort of trailing the sun and disappearing. So they're going down to do battle. And they have all these stories about Venus and the sun together beating back pestilence and disease and war and all these enemies of mankind and basically making the world safe for humanity.
Well, modern culture in the last 100 years or so, there's been stories like Edgar Rice Burroughs where life on Venus could have arisen. And part of that comes from the steady knowledge and increased knowledge scientifically of Venus, like what happened in 1761 with the Venus transit. What happened during that transit?
Yeah, I love that story. That is basically the discovery that Venus had an atmosphere by a very astute observer in St. Petersburg, Russia, an astronomer named Lomonosov. And he noticed, Venus does these transits in front of the sun, as you mentioned, in the sort of weird pattern. It does it in pairs of 8 years, separated by about a century. In fact, so we just had a Venus transit in 2004 and another one in 2012, and we won't again for almost another century. And when it does that, you can learn a lot because you see the little disk of Venus, of course, the little dot passing across the sun. And historically, we've learned a lot. It helped us figure out the size of the solar system through the geometry and all that. But this particular discovery that you mentioned, Lomonosov noticed that it wasn't just a circle moving across the sun, that there was this weird effect when Venus was just touching the sun on one side and then the other, that there was this weird, what he called the black drop, this weird sort of extension of the circle to this strange sort of stretched out shape, which we now associate with refraction of the atmosphere of Venus that you can see in those moments when it's just touching the sun. And he was the first one to deduce that, and he said Venus must have an atmosphere, and he was right.
Yeah, and of course that feeds into all kinds of stories. This is the first planet beyond Earth that had an atmosphere, and so what would life be like, et cetera, et cetera. So indeed, Venus has been very important to in our literature and culture.
Yeah, and it's not that long ago that we figured out, in some sense, the way Venus really is. Of course, we still have a lot to learn, but the basics of how different it is from Earth. And a lot of the science fiction that I grew up reading was written when we still thought that Venus might be an oceanic planet. So a lot of the science fiction stories that were written in the 40s and 50s, a lot of these classic ones by Isaac Asimov and people like that, they still have this oceanic Venus, and, the Earth explorers are, they were in submarines exploring exotic creatures under the water there.
Today, there's one spacecraft that's orbiting Venus, and it seems like it's been a planet that's been observed by many different space agencies. Do you remember the one that's there now?
Yes, we are fortunate that our colleagues in the Japanese Space Agency have a spacecraft called Akatsuki. It's a word that means dawn in Japanese, which makes sense given what we were talking about, Venus being the morning star. And it's actually a spacecraft that has a sort of heroic story because it was launched in 2010, made it to Venus just fine in less than a year, and then it was supposed to burn its main engine for 12 minutes and go into orbit, and sadly something went wrong with the main engine and it spun off helplessly around the sun. But amazingly, it spun off helplessly around the sun on a trajectory that was going to bring it back to Venus 5 years later. So they had a chance to get into orbit, but they didn't have a main engine. But these very clever Japanese engineers figured out if they take these little maneuvering thrusters and fire them all in the same direction for 20 minutes, which they were not designed to do, that they might be able to get it into orbit. And of course, they couldn't practice it because they only have enough fuel to do it once, but it worked. And now Akatsuki's in orbit and making all kinds of neat observations of the atmosphere and the clouds and some observations of the surface at these wavelengths where you can peer a little bit through the clouds. And so it's a wonderful sort of a resurrected mission.
NASA's currently got some proposals for Venus in a set we call the New Frontiers call of 4 missions. And so we're analyzing those, and perhaps, we'll be selecting a Venus mission, which would be pretty spectacular if we're able to do that.
That would be terrific. I'm hopeful that one of these years NASA will be returning to Venus. There's certainly a lot more left to explore there.
Well, what would you do from an exploration point of view? What would be the top science activities that we ought to be going after?
I mean, Venus is a challenging place to explore. Part of the reason we haven't been there more is that the surface environment is so severe. You can't see the surface from orbit like you can from Mars, at least not in the visible. But there are a few things that would really help us with our understanding the history. One is that we've never really got good measurements of the rare gases, what we call the noble gases, and their isotopes. Other things we would love to do are orbit again with a really much more sophisticated radar. Now we can do these. We have these radar interferometers, which, for instance, on Earth, you see these. They do these amazing measurements where you can see the San Andreas Fault. You can actually see the motion because they're so sensitive. And so, if we had something like that on Venus, we could actually see if it's tectonically active, let alone map the surface in much more detail. And of course, also, we would love to really land on Venus. The Soviets did it a long time ago. The Russians did it decades ago. But now, again, with modern instrumentation and armed with the sort of more sophisticated questions we have now based on what we've learned, we'd love to dig into the dirt and measure the minerals and really look for clues to the history of that surface and the history of climate and some of those big mysteries. What happened to the water on Venus? How long ago did Venus lose its water, and what has the climate done since then?
Unlike the Earth, Venus doesn't have a moon. Why do you think that happened?
Our current understanding of why the Earth has its moon, again, has to do with that early impact history, the sort of last stages of formation of the Earth. That very, we think that a Mars-sized object hit Earth, and in just the right way, that it spun a glowing ring of material into orbit around the Earth, which then coalesced to form the moon. And that was actually, if you think about it, a very somewhat random and very specific event, that if that impact hadn't happened or it had a slightly different geometry, Earth might not have a moon, or it might have several moons like Mars, so the fact that Earth has its moon, we understand, comes down to this slightly chaotic and random event. So it may just be as simple as Venus's final stages of formation happened a little bit differently from Earth's in terms of the sizes and geometries of those last few big crashes that formed Venus.
We all get into this business some way or another, and I refer to that as that gravity assist that pulls you in. What's your story in that?
Well, I'm not one of these people that had to figure out what I was going to do and had many false starts. I feel like I was always on this sort of path, so I didn't need too many gravity assists. I was sort of, I don't know what, it just seemed, partly I was born at the right time. Literally, my earliest vivid memory is the Apollo 11 landing on the moon. And, I was in fourth grade, and I was just so captivated. And I think you'll find a lot of space scientists of my generation will say the same thing, that Apollo, was a big event for them. But then also, when I was young, I had some influential people in my life and mentors. Actually, it turns out one of my dad's best friends was Carl Sagan when I was little. They were both Harvard professors, and this was before he was famous. He was just this cool guy we knew who would lead these public observing nights at the Harvard Observatory and, let us go run the controls at the planetarium. And, so that was certainly an influence. And then when I went to college, I had some great mentors. In fact, my first semester at Brown University, I took a class called Mars, the Moon, and the Earth with Jim Head, who is, Jim Head's a little bit of a Pied Piper of planetary geology. He gets a lot of young students excited, and I was one of those. And then in college, I got a summer job working for Professor Head, analyzing some of the new Viking images of Mars, which were just a few years old then. And, one thing led to another, and I just was pulled in and captivated and, never lost that excitement.
Well, we had a great time talking about Venus, and I really appreciate the opportunity to chit-chat about one of my favorite planets.
Well, thanks a lot. It's been a real pleasure for me.
Join us next time as we continue our virtual tour of the solar system. I'm Jim Green, and this is your Gravity Assist.